Thanks to the James Webb Telescope, we are able to peer deeper into the oldest and most distant mysteries of the cosmos than ever before. And in doing so, we are constantly encountering things that, according to current theories, should not even exist. These seemingly impossible discoveries have already shaken our understanding of space, time, and the origin of the universe. More and more renowned scientists are now wondering whether our cosmological worldview needs to be revised in key areas. Just recently, leading researchers gathered at a symposium in London to discuss precisely this question. What if we have been fundamentally wrong about crucial aspects of the evolution of the universe? Is the standard model of cosmology still tenable? And why have the Webb observations triggered a veritable astronomical crisis? Stay tuned until the end and find out with us. Imagine you want to reminisce and look through baby photos of your children, but instead you come across pictures of them already over 2 m tall. Of course, you wouldn't immediately wonder how this could be possible. And that's exactly how astronomers felt. In this case, the babies were astonishingly large black holes and galaxies in the early universe that were completely unexpected in this form. With the James Webb Space Telescope, we are discovering more and more objects and structures that hopelessly exceed the limits of our established models and theories. And cosmologist Zubair Sayar from the University of Oxford aptly summed up this tricky situation. Quote, "In cosmology, we are still working with a model that was first established in 1922. Of course, we have great new data today, but the theory we rely on is no longer up to date. And I'm not the only one saying this. More and more respected astronomers are coming to the same conclusion. But what exactly did Webb discover to elicit such profound statements from the experts? Why are experts saying that what Webb has found no longer resembles a universe we thought we knew? Well, to understand this, it's worth taking a look at the amazing discovery made by a team led by astrophysicist Pablo G. Perez Gonzalez from the Center of Astrobiology in Madrid. Specifically, the researchers encountered 9 mysterious light sources at the outer edge of the observable universe. 6 of them had a redshift of 17, and 3 even have a redshift of 25. And perhaps a quick reminder of what this means. Redshift shows how far the light from distant objects has been stretched. The higher the value, the further away and therefore older the light we see. As a result, the study of distant cosmic structures is always like an optical journey through time. Specifically, a redshift of 17 shows us a universe when it was only 200 million years old. At a value of 25, we see the cosmos only about 100 million years after the Big Bang. And according to Perez Gonzalez, these are the deepest observations the James Webb Telescope has made so far. Final confirmation is still pending. But if these light sources are indeed located at these extreme distances, it means that the early universe was significantly more active in its first 200 million years than anyone had previously thought possible. Why the discovery contradicts our models. However, this discovery comes as something of a surprise, to put it mildly. According to our standard model of cosmology, the universe was a very quiet place in the first 100 million years after its birth. At that time, there was no light, let alone stars and galaxies, just a vast, dark, and almost empty space. Experts aptly refer to this era as the Dark Age, and it describes a phase in which the cosmos was still cooling down from the enormous heat of the Big Bang and expanding steadily. The mysterious dark matter which makes up most of the gravitational mass of the universe began to accumulate into large clumps due to gravity. But despite all this, the universe still did not contain any stars or galaxies at that time. It simply set the stage for all the countless structures that were yet to come. And that is precisely the problem, because what the James Webb Telescope has discovered simply does not fit into this picture. But let's be clear, this is neither the first nor the only Webb discovery that has astronomers struggling to explain. Webb has previously identified early galaxies with redshifts of 10 to 12. This distance is not really surprising in itself. But what is all the more surprising is the mass of these galactic premature babies. Some of them are almost as star-rich as our Milky Way is today. Even though, according to our theories, there was not enough normal matter at that time to form such heavy weights. The case of Jade's GSZ 14-0 is similarly puzzling. It has a redshift of about 14.32, making it the oldest confirmed galaxy ever. We see it as it looked only 290 million years after the Big Bang. Yet, it already weighs around 500 million solar masses. And we have no idea how it could have reached such proportions in less than 300 million years. And the same applies to the galaxies that Perez Gonzalez's team of researchers has tracked down. After all, these already existed 100 to 200 million years after the Big Bang. Or did they? Well, that's precisely the question. As things stand, we simply don't yet know whether these are really galaxies. So far, the 9 objects have only been classified as light sources whose exact origins are unknown. However, astronomers emphasize that according to established models, the formation of stars was not possible in this early phase of the cosmos. And so, some researchers are approaching this mystery from a slightly different angle. What the structures could really be. Some scientists speculate that the objects are not galaxies, but rather so-called primordial black holes that formed immediately after the Big Bang due to extreme density fluctuations in the newly born cosmos. This hypothesis was originally proposed by Stephen Hawking and is based on the assumption that the corresponding regions immediately collapsed under their own gravity and formed black holes. And if the light sources discovered by Webb really turn out to be primordial black holes, this would revolutionize our understanding of the early universe. Stars and galaxies would no longer be the only structures that formed so early on, and it would explain why such luminous objects already existed at that time. Of course, unlike stars, primordial black holes would not shine themselves, but Webb could still see them because they attract gas and dust from their surroundings. As matter falls into the black hole, it becomes extremely hot and begins to glow. And these objects may also stimulate star formation in their surroundings, further amplifying the observed light show. Astrophysicist Andrea Ferrara of the Scuola Superiore Santa Anna in Pisa says, if stars cannot explain the brightness or the number of objects observed, something else must be producing the light, and that can only be a primordial black hole. Some researchers are taking up this assumption and speculating that primordial black holes could provide groundbreaking clues about the very first moments of the universe. And yet, we should not forget that these are still pure hypotheses that will need to be confirmed by further observations in the future. The same applies to the so-called little red dots, or LRDs for short, which have been keeping the scientific community in suspense practically since the scientific launch of the James Webb Telescope. Initially, these objects were thought to be small, compact galaxies, but follow-up investigations showed that they are something completely different, something we have never seen before, the precursors of supermassive black holes. Webb has now added more than 300 of these small red dots to the star charts. However, this high number contradicted our previous understanding of the early cosmos, but it was also accompanied by a number of other question marks. The assumption that these are active galactic nuclei is contradicted by the fact that they do not emit detectable X-rays. Furthermore, the LRDs show hardly any variation in radiation intensity in the infrared range, and a new research study shows what this could mean. So the objects are probably not early galaxies at all, but supermassive stars. To put this into context, we are talking about hypothetical stars at way up to 100,000 solar masses. But that's not all, because researchers also suspect that these stars represent an important intermediate stage in the formation of black holes. The authors of the study assumed that such celestial bodies could only have formed in the very early cosmos. At the end of their stellar lives, they probably exploded in a massive supernova, creating black holes that may have served as seeds for the latest supermassive black holes. This would also explain why we are already discovering such colossal mass monsters in the early history of the universe. In detail, the experts believe that LRDs show the direct light of supermassive stars that are actively growing and at the same time on their final stages. Their explosive demise is likely imminent. The study authors explain, quote, this short lifespan is consistent with the rarity of LRDs, suggesting that they represent a fleeting but crucial phase in the formation of galaxies and black holes. To find out whether these structures are indeed early giant stars, astronomers developed models and compared them with observational data from the James Webb Telescope. The results were astonishing. The brightness and light spectrum of the simulated stars matched the actual measurement data of the LRDs very well. Experts say, in summary, our model of supermassive stars provides a remarkably simple and consistent physical picture for LRDs. However, the hypothesis has not yet been definitively confirmed. Further observations are needed for that. But if it turns out that LRDs are indeed supermassive stars, it would be an absolute milestone. We would then have found a plausible explanation for one of the greatest astronomical mysteries of our time. Mysterious red dots in the universe could be supermassive stars. And now we'll give you a plausible explanation for how you'll never miss a new video from us again. Subscribe to stay up to date from now on. See you soon.